హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు JMK ట్యూటోరియల్స్. ఇప్పటివరకు ఎవరైనా మీరు మన ఛానల్ ఇంకా సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే ప్లీజ్ సబ్స్క్రైబ్ అండి. మీరు సబ్స్క్రైబ్ చేసుకోండి, మీ ఫ్రెండ్స్కి షేర్ చేయండి. ఓకే, థ్యాంక్ యూ ఫర్ యువర్ cooperation and support up to now. Thanks a lot. Today in the digital system design and DLD series point of view, we have to see the edge triggered SR flip-flop. Okay, so in the previous classes already we have already covered some videos on the SR flip-flop also. Now we have to focus on edge triggered. Okay, edge triggered flip-flops concept, right? So see here, generally we know that the basic diagram for SR flip-flop, just I can draw the in terms of a block diagrams. Actually, I think everyone having this diagram. With the help of a NAND gates, we can design the SR flip-flop. I hope this circuit is already everyone having some idea about this one. It is nothing but a latch. This can be synchronized with the help of a clock signal. We are providing the input signal yes R. Okay, so this is generally called as S bar. It is generally called as a R bar. This output can be treated as a Q. This output can be treated as a Q bar. So this is nothing but SR flip-flop circuit diagram with the help of a NAND gates. But instead of our edge triggering concept, I can mention this one. So this is a clock signal, right? So it can be represented like this. So it is a positive edge. So I will represent this complete circuit in terms of some block diagrams. It is consisting of S, R, it consisting of a Q bar. Okay, it is a SR flip-flop, right? So it is nothing but a edge trigger. Okay, if the bubble is there, that is nothing but it is a positive edge trigger. Okay, it is a SR flip-flop. It is a clock signal. So this figure shows that positive edge triggered flip-flop. Okay, this is a positive edge trigger flip-flop. Suppose S, R, Q and Q bar are the outputs. It is a SR flip-flop again. Okay, if suppose clock with some bubble is there, so this is generally called as a negative edge triggered flip-flop. It is nothing but a negative edge triggered flip-flop. Okay, this figure shows the negative edge trigger flip-flop. We know that generally the characteristic equation for flip-flops, clock signal S, R, Q bar, right? So whenever the clock, whether it is a 0 or 1, okay, whatever the SR values, the output no change. NC represents no change. Okay, because of we are dealing with the post rising edge. Okay, edge trigger. So if it is a positive edge, when the clock is a rising edge, at that time 0 refers to the memory I can call is a no change condition. Okay, no change or memory condition. Next rising edge 0 1, it is a reset condition. Next rising edge when s is equal 1 r is equal 0, set condition. And the next 1 1 consideration, it is nothing but a 1 1, it is the invalid. Okay, so this is nothing but SR flip-flop diagram. Okay, so here I can find out the characteristic equation. Okay, now I have to find out the CH equation. So for that purpose I have to take the K map from this one in terms of S and R and Q values. Okay, so I will draw some neatly. So let us see here. I will draw the we have to take the three variables, that is nothing but S, R and Q. So now characteristic equation is nothing but this equation, the value of the output at Q of t after the, okay, we have to characteristic equation is nothing but which tells the what is the output of the SR flip-flop after the Q of t clock pulses. So that is nothing but next state. So for this one, let us see here. We will take the three variable K map. It is nothing but SR. It is nothing but Q of t. Okay. So 0 0 0 1 1 1 1 0. It is a 0 1 consideration. So let us see here what is the output in this case when the input 0 0 at that time. So here when the input 0 0, when the input 0 0, Q of t is no change. That means whatever the Q of, if it is a Q of t is a 0, it is also 0. It is also 1. In the 0 1 condition, in this case, Q of t value is set to 0. So if it is a 0, 0. If it is a 1, it's set to 0. In the 1 1 condition, it is an invalid condition. That is nothing but we can treat it as a don't care condition. Okay, in 1 0 condition, if it is a 0, it can set to, it is a set condition because of it is a set condition. Q value so set to 1. So Q of t value is 0, then it's set to 1. If the Q of t value is 1, it's set to 1. So because of it is a set condition, if it is a 1, it maintains a 1. So this is nothing but how to map the table. So it forms a one quad. Okay, and it is also a one loop, and it is also a one loop. So this quad is common is nothing but first value. Therefore from this we can get the S value. Okay, plus in these two, one is common and these two 0 is common. 0 is nothing but R bar. Therefore one is nothing but Q of t into R bar. So this is nothing but characteristic equation of the SR flip-flop. Okay, this shows the Q of t plus 1, that is nothing but CH equation or characteristic equation of the SR flip-flop. I hope this video is very clear up to now, right? So next one, excitation table of a SR flip-flop. Excitation table of a SR flip-flop. Obviously, everyone having a doubt what is meant by excitation. Okay, excitation So generally excitation means that it is nothing but input, right? Response is nothing but output. So excitation means that it tells the, okay, so we can set the flip flop 0 to 1 or 1 to 0 in the output. So what are the possible requirement possibilities for the input? So let us see here and okay, ఇక్కడ observe చేశారంటే, so clock changes, okay, clock changes, okay, clock changes, it is nothing but required values if you want to change that. So from here, from to yes, okay, let it, it's very important, see here very carefully guys. So from means that we don't know exactly, okay, initially it is a 0 0 0 is the present state, next state is equal 0, then 0 to 0 means that it maintains the same value. So 0 to 0 means that same values ante enti, when s value is equal 0 means that it is nothing but a reset condition, at that time output is also 0. So moreover, R value is also 0 is nothing but it is nothing but 0 0 means that memory state which maintains the same. Or else if the R value is also equal to 0, one possibility, it is also nothing but a 0 1 combination means that it is nothing but a reset condition. So whether R value is 0 or 1, this maintains the same values or it maintains the same 0 value, that is generally called as a memory state. So we can change that value can be with x because of don't care, okay, it may be whatever the value, okay na. So possibilities for whatever the it is acceptable for 0 and 1 condition also. Suppose if the input is 0, I mean present state is next, if present state is 0, it change from state 0 to 1 means that it is nothing but next state. So 0 to 1 ki ravalante what are the possibilities? Set condition. So for that purpose the flip flop yes must be compulsory 0 or must be 0. We don't have any other possibilities. In case if 1 to 0, if the present state is 1, next state is equal to 0, it is a reset condition. At that time s is equal to 0, r is equal to 1. In case 1 to 1, it is nothing but invalid condition, okay. So invalid condition means it is nothing but a, whether it is a maintains the same value, right? If it is a set condition, okay, if it is the 1 0 set, so 1 to 1, so 1 is nothing but set, so set condition possibilities is if it is a 0, it maintains the same values, okay. So therefore it accepts the two values, therefore I can replace this with x, that is nothing but don't care condition. So this is nothing but excitation. So for our convenient point of view, I can change the corresponding with, so this is nothing but q of t, q of t plus 1 is the next state, it is nothing but inputs. So this is nothing but excitation table of the SR flip flop. I hope this video is very clear for you. If you know this concept, you can extend this concept to the any flip flop, whatever it is. It is a D flip flop or maybe JK flip flop or maybe SK, SR or it may be T flip flop, whatever it is. If you know the concept of excitation table and how we can draw the uh, characteristic equation from the K-map, you can have a plenty of knowledge in the flip flop. Okay, not an issue. Okay, so thank you for supporting GMK tutorials for you. Okay, I hope this video is clear for you. Edge trigger means that only SR flip flop is activated for edge of the clock signal. That is one of the most important point you have to remember. Okay, I will. In case if the flip flop is going to be produce the outputs only for positive edge of the clock, that is nothing but positive edge triggered flip flop. If the flip flop is activated only for negative edge of the clock, that is nothing but negative edge trigger flip flop. It is purely depends on the clock whether it is a positive or negative. So positive trigger clock can be represented as a triangle, negative trigger can be represented as a bubble with a triangle. So that is nothing but SR flip-flop edge triggering of SR flip-flop. Okay, so in the next video we will see how can you design the edge trigger D flip-flop. Okay, in the next video we will see this edge trigger D flip-flops. Okay, so this is the next topic. So thank you for watching GMK tutorial. Thank you guys.